So this is how you calculate probabilities using Poisson formula and table. The question has mean of 8 calls in every 5 minutes. So it means that the 5 minutes is the interval duration of time. So here you can write X as the number of calls in 5 minutes. So the question asks you to find the probability that in the next 5 minutes. So it means it's still within the 5 minutes. So first you can write probability X equals to 0, for B X equals to 5, while the X is greater or equal to 3, while D X is less than 4, and E is probability 3 less than or equal to X and less than or equal to 5. So there are two ways. Firstly, we can use the formula, which is probability X equals to R. So as you can see here, you can use this formula. So to use a table, you can draw a diagram beside so you can get to understand more. So here it means X greater or equals to 0 minus with X equals greater or equals to 1. So you can look at the table and you just calculate it and you will get the answer for it. As you can see here, it is the same as the question on E. You just use the table and you can calculate and get the answer for it. While for question C, which is probability X greater or equals to 3, you can use a formula and you can also use the table. But using the formula, it will require you to get the answer for 2 to 3 minutes, while using table you could get only in 5 seconds because you just look at it. For probability X less than 4, you need to minus 1 with the probability to get the answer, and the probability you can just check on the distribution table. For E, when using a formula, you can just sum all of the probability using the formula and you will get the answer, while if you use the table, you need to minus the X greater or equals to 3 with the greater or equals to 6. And for the answer, it is suggested for you to put 4 to 5 decimal places. So the question shows that the machine occur at a rate of 2.5 per month. And question E, we need to find the probability for particular month, which means X is equals to number of breakdown per month. For question B, we need less than 10 breakdowns occur in 3 months period, which means Y equals to number of breakdown for 3 months. While question C is exactly 3 breakdowns occur in 2 months, which you can use Z equals to number of breakdown in 2 months. So we can use this different alphabet to categorize.
For more than, we use the symbol of greater than 3, less than, we use the symbol of less than 10, and for exactly 3, we use equals to 3. X is the number of breakdowns per month, that's why it's 2.5. However, for Y, it is for 3 months, so we times it with 3, so that's why we get 7.5. For A, we just read it from Poisson's statistical table, so we get 0.2424. For B, we use 1 minus probability of Y greater or equals to 10, so we get that. For exactly 3 breakdowns, we use the box just like Ms. Red said. We use number 3, 4, so we color the number 3 and then that's why we get 3 minus 4, we got 0.1403. From the question, we can see that the lambda is equals to 30 per hour. So for 5 minutes interval, we use it as X, for 15 we use as Y, and for half an hour we use Z, and 10 minutes we use M. We're going to use different variables to represent different intervals. So from the question given, it says 30 cars in 1 hour. So as you guys know, 1 hour is in 60 minutes. So for 1 car, we get that 1 over 30 times 60, so we get 2 minutes. So 1 car is equals to 2 minutes. However, the question asks for 5 minutes. So for 1 minute is equals to 1 over 2 car. So for 5 minutes, 5 over 2, because 1 over 2 we times it with 5. For A, we will use a formula to get that answer. Probability of X greater than 3 is equals to probability X greater or equals to 4, so we read it from the Poisson table. For this question, it asks for 15 minutes, so 5 over 2, we times it with 3, that's why we get 7.5 cars. Same goes with question B, we just read this from the table. For 30 minutes interval, we will use the formula to get that answer. Question E, we will get that the lambda is equals to 5, so we will use a pelengkap and we just read it from the Poisson table.